Hello, this is Gabe. I'm going to show you how to solve a 3x3 matrix with Cramer's rule. These are the formulas: x equals dx over d, y equals dy over d, and z equals dz over d. D is the determinant. The equation forms are x plus 2z equals 9, 2y plus z equals 8, and 4x minus 3y equals negative 2. The matrix form is 1, 0, 2, 0, 2, 1, 4, negative 3, and 0. The determinant is D. We'll solve for the determinant here. Let me change my color on my cursor. There we go. Okay, so you just do, so back here in the matrix form, say you're finding the determinant. You want to find 1. So you just cross this out and cross this out. And you have 2, 1, negative 3, 0, like here. And say for like 0 right here, you just do 0 and you cross out. Let me change the color again. So you're trying to find 0, you just cross out 1 or you just cross out, 2 axes right there, so you get 0, 1, 4, 0. And right here you have 0, 1, 4, 0, and then you can do that for 2 as well. And you have, you multiply this, and this right here, this, and then you add them. So you have 3 minus 0 plus 2 times negative 8, which gives you D equals 3 minus 16 equals negative 13. And then you have D equals negative 13. So the determinant is negative 13. Alright, now that you know the determinant, all I have to do is find dx, dy, and dz, substitute them into the formula, and then you'll have x, y, and z. So first you find dx, and you just use, first you have to have the matrix. So we switch to white, and the matrix is 9, 8, negative 2, 0, 2, negative 3, 2, 1, 0. And the reason this is a different matrix, 9, 8, and negative 2, is because if you go back here, 9, 8, and negative 2 right here, they are at this side of the equation, they are on the right side, and so you have to put them in, and this is x, y, and z, and since you're working with dx, you have to substitute this right here, 104 for 9, 8, 2. So that's the matrix. And so you start by solving. Sorry about that, I pressed the wrong button, but I was just going to change my color. But I'm going to solve now for dx, and you start with dx equals 9, 2, 1, negative 3, 0 times, or negative 0 times, and you would put in values right here. Since it's negative 0, you know that it's not going to be anything because 0 times something is nothing, so I'll just put an x there because it's not going to end up with any values. And then plus 2, 8, 2, negative 2, negative 3. Just like earlier, you do the bars to get stuff like this. If you're trying to find 0, you just do that and you have 8, negative 2, 1, 0. So now that we started, we can continue solving. And dx is equal to 9 plus 3 minus 0 plus 2 times negative 24 plus 4. Alright, and now we have dx equals 27 plus 2, and then we have negative 20 right here. and we go to our next page, continue solving. Dx equals 27 minus 40, and dx equals negative 13. And so I should start writing these down. Let's go back to page 1, and we will write down that d equals negative 13, and dx equals negative 13 as well. And so we'll go to the next page and solve for dy, because we have d and dx. So I'll go back to white and just dy. So anyways, so dy, what you do is you take the matrix 4, 0, 4, 9, 8, sorry, 1, 1, 0, 4, 9, 8, negative 2, 2, 1, 0, and since, yeah, just like earlier, you have, this is x, y, z, and you're solving for dy, so you want to substitute 9, 8, and negative 2 into this column, and that's what I did there. So now you can solve with the bars, or get your values. So you have dy equals 1, 8, 1, negative 2, 0, minus 9, 0, 1, 4, 0, plus 2, 0, 8, 4, negative 2. And you have dy equals 1 times 2 minus 9 times negative 4 plus 2 times negative 32. And you have dy equals 2 plus 36 minus 64. And now you have dy equals 38 minus 64, and dy equals negative 26. And now we solved, so I'll go back and write this down on the original page, that dy equals negative 26. And now all I have to do is solve for dz, that's the last one. And so we'll go to a new page, and what I'll do is solve. So what we'll do is dz matrix is 1, 0, 4, 0, 2, negative 3, and 9, 8, 2. You have it substituted into the z, because you're working with dz, so the z column, and you just do the bars to get your values so that you can solve, and you'll have one with 2, 8, negative 3, negative 2 in the bars, minus 0, and we know that anything with 0 will be no value, will just be 0, so we'll just cross that out. And then we'll do plus 9, and in the is 0, 2, 4, negative 3. And then we continue on with the solving on the next page. We have 1 times 4 plus 24 minus 0 times, I'm backtracking. But you just, subtract 0 plus 9 times negative 8, and you have 20 plus negative 72, which leaves you with dz equals negative 52. I'll write that down. dz equals negative 52, and I didn't write that down very clearly, so I will write it down on the next page. Okay, so we have d equals negative 13, dz equals negative 13, dy equals equals -26, and dx equals -13, and dz equals -52. All I have to do is substitute in for x equals dx over d, y equals dy over d, and z equals dz over d. So, to do a substitute, so x equals -13 over -13, which is 1. Y equals -26 over -13, which is 2. And z equals -52 over -13, which equals 4. So we have solutions at 1, 2, and 4. And that's complete, so that's how you solve a 3x3 matrix with Cramer's rule using Dosuri is what I did. So yeah, that's it. There's a solution. That's how you solve.